Testing 1, 2. Testing 1, 2. out of it. There you go. So you're the one on home. The video on this. Huh? You're tired. You're supposed to be doing it.
Good morning, learners. Good morning, teachers. My name is Mohapi, and I am working here at Motel District as the subject advisor for mathematics. Let me take this opportunity to welcome everyone viewing this program, and I hope at the end of the day, you will be inspired and motivated, more especially you learners, considering the fact that this coming Friday, we will be writing mathematics paper 1. So one of the topics that will be examined in this coming mathematics paper 1 will be number patterns. As a result, in today's lessons, for the next 2 hours, we'll only be focusing on the number patterns. I hope it's very clear. And because we are doing we are doing the revision now, we are preparing ourselves for the September examination, which will be written this coming Friday. There will be lots and lots of activities that I'm going to engage you in. Learners, I hope you got your pens are ready. I hope your books are ready, because I'm going to give you lots and lots of activities. So your task will be to respond to those activities, and then at the same time, I will also work out the solution. Then you can compare your workout against mine. I hope you'll find this session inspiring and fruitful, and you will benefit a lot. Because please always assist your learners. Be there for your learners. Support them, because we really want to see them passing mathematics at the end of the year. Thank you. Without any waste of time, let me study the topic for today. Number patterns. The topic for today is number patterns. And we know number patterns can take different forms. So I'm going to take you through this first exercise. And then the next exercise, I think you and us must be able to do it. We've got different types of number patterns. The first one is the linear number pattern. The question states, consider the following linear number pattern. If you look at, once you talk of a linear number pattern, then you as a learner, you must know exactly what a linear number pattern is. That is very much crucial. So in this case, once you talk of a linear number pattern, we know that a linear number pattern is a pattern in which the first difference is common. A linear number pattern is a pattern in which the first difference is common. Let's check the example that is projected on the screen. 7, 12, 17. And it is clearly stated that this is a linear number pattern. It is clearly stated that this pattern is a linear one. So we know for sure that once it is a linear number pattern, then the first difference must be common. Let's check. 1.1. We've got 2, got 7, got 12, and you also have got 17. It's a number pattern. Let's check the first difference. Difference between the first two terms. 7 minus 2 gives us 5. Let's check the difference between these successive terms. 12 minus 7 gives us 5. Third difference, 17 minus 12 gives us 5. This shows that this is a linear number pattern because the first difference is common. We only determine the difference here, 7 minus 12. The answer you get when you subtract is called the difference. So 7 minus 12 gives us 5. 12 minus 7, 5. 17 minus 12, 5. So in all these instances, the difference between successive terms is 5. So once the first difference is common, that pattern is called linear number pattern. So it means to determine the next term, we just have to keep on adding the common difference. Thank you. Check. We agree that the first difference is 5. It's 2. In 2, you add 2 plus 5 will give you 7. 7 plus 5 will give you 12. 12 plus 5 will give you 17. Then you continue the sequence. Then you continue the pattern. 17 plus 5, I think 17 plus 5 will then give you 22. 17 plus 5 will then give you 22. Again, 22 plus 5 will then give you 27. What does that mean? If we answer the question states, write the first question, 1.1, write down the next 3 times of the sequence. Write down the next 3 times of the sequence. So how do we do that? We have realized that the common difference is 1. So we keep on adding the common difference. The common difference is 5 in this case. So 17 plus 5 gives us 22. 22 plus 5 gives us 27. 27 plus 5 will then give us 32. So the next 3 terms of the sequence will then be 12, will then be 22, 27, 32. I hope you got that one clear. The first question states, write down the next 3 terms of the sequence. Because it is a linear number pattern, the first difference is common. So in this case, the first difference is 5. So to determine the next term, you just add 5. 17 plus 5 gives us 22. 22 plus 5 gives us 27. 27 plus 5 gives us 32. So when answering 1.1, write down the next 3 terms of the sequence. The next 3 terms of the sequence will be 22, 27, and 32. 1.1, I think we're happy. Check 1.2. 1.2 states, determine the nth term of the sequence. Remember, this is a linear number pattern. So the linear number pattern is given by Tn equals to An plus B. The linear number pattern. Once you talk of a linear number pattern, we know that it's An plus B plus B. What does this A represent? In this case, A represents common difference. A represents common difference. So in this case, our common difference was 5. This means that A is equals to 5. So if A is equals to 5, we then substitute the value of A in this general term formula. Therefore, the nth term will then be equals to 5n plus B. 5n plus B. Meaning that if the question states determine the nth term of the sequence, all we have to do is to determine the value of A and the value of B. The question states determine the nth term of the sequence. Our task is to determine the value of A and the value of B. So fortunately enough, we already have the value of A, because A is the common difference. A is the first difference. So first common difference is 5. Substitute A by 5, 5n plus 6, plus B, plus B. So the question is, how do we determine the value of B? I hope you still remember. How do we determine the value of B? Let's check. To determine the value of B, we use all these terms that are already given there. You can say the first term is 2, the second term is 7, the third term is 12, the fourth term is 17, anyone. But I always advise us to use term number 1 because substituting with 1 becomes so easy. If you can check term number 1, our first term is 5. Our first term is 2. Sorry for that. Slovenly word. Our first term is 2 because 2. So the first term is 2. Second term is 7. Third term is 12. Fourth term is 17. So our first term is 2. So we say we substitute n by 1. We substitute n by 1. Remember, it's not tn, the nth term. So t1 is 2. Meaning that we substitute n by 1. Here is tn. Term number 1 is 2. 5 substitute n by 1 plus b. Now we determine the value of b. We've got 2. 5 multiplied by 1 gives us 5 plus b. Transpose 5 to the left, you'll be left with b on the right hand side. On the left hand side, then it will be 2 minus 5, which will give you negative 3. 2 minus 5, which should give you negative 3. That is our negative 3. Then we conclude. Therefore, the nth term will then be equals to an plus b. Our a is 5. It's going to be 5n minus 3, because the value of b here is negative 3. Our value of b here is negative 3. So what do? We substitute this negative 3 in this formula. Therefore, we've got tn is equal to 5n minus 3. I hope it's clear. Determine the question states, if you remember the question properly, the question states 1.2, determine the nth term of the sequence. Determine the nth term of the sequence. So the nth term of the sequence is given by n is equal to an plus 5 plus b. And this a represents the first common difference. So the first difference, which is common in this case, was 5. As a result, a is equal to 5. You substitute a by 5, you've got tn is equal to 5n plus b. So we need to determine the value of b. Check term number 1. Our first term there is given as 2. From the sequence, you can check first term is 2. So our first term, if our first term is 2, what do? Say t1 is equal to 2. It means we're going to substitute the value of n by 1. 2, 5 into 1 plus b. 5 multiplied 1 gives us 5. Then we transpose 5 to the left. Got 2 minus 5, which will give you negative 3. On the right hand side, you're only left with b, meaning that the value of b is equal to negative 3. Therefore, the nth term will then be equal to 5n minus 3. I hope you're happy with that solution. I hope you are happy with that solution. That is our nth term. Let's look at the next question then, 1.3. Because 1.1 and 1.2 have been answered, and I hope we are still following. Let's answer 1.3.